Okay, welcome back. So right now we're going to be looking at past questions on the topic of scalars and vectors. We have certain problems here. I would request you pause, try solve them, and then come back. Okay? We have approximately 14 questions to answer. Alright? 1. State the triangle law of vector addition. Okay, I'm sure we know that, but just in case you don't, you can go back and look at the course. It was mentioned there, the triangle law of forces, where we talked about if two forces acting at a point are represented in magnitude and direction by the two adjacent sides of a triangle taken in order, then the third side of the triangle represents the resultant of the forces in magnitude and direction taken in opposite order. Okay, so that's the answer for number 1. So number 2, which of the following pairs of physical quantities is made up of vectors? So we have speed and displacement, we have mass and force, displacement and acceleration, momentum and length. If we look at this, we'll see that speed is not a vector quantity because speed doesn't require direction to define it. Okay, velocity does, but not speed. So this option is off. Okay, because we need a pair of vectors. So we have mass, we have force. Mass is not a vector. It doesn't need direction to define it. We have displacement and we have acceleration. Now, displacement is a vector. It needs direction to define it. If there's no direction, then it's just distance. Acceleration, of course, is a vector because it needs direction to define it. You have acceleration as change in velocity, and velocity is displacement over time. Velocity has to do with direction, so acceleration definitely has to do with direction too. So you see, this is our answer C. Do we have to check D? Obviously, D is not the correct answer. Alright, so even if you don't know anything about momentum at this point, you should know that length is not a vector quantity. So obviously D is off as an answer. So our answer is C. Which of the following quantities is a vector? Okay, so we have volume, we have momentum, we have energy, and we have speed. Okay, so volume obviously is not a vector quantity. Momentum is mass times velocity. So momentum is a vector quantity because it contains velocity. I know we haven't done this yet, but very soon we're going to be dealing with momentum. Okay, so energy, nah, not a vector quantity, has no direction. Speed has no direction. You can define energy by just magnitude alone. Okay, you don't need direction to define energy. Speed also doesn't need. So B is our answer, momentum. 4. The pair of physical quantities consisting of vectors only are. Okay, so this question is from JAMB 2005 JAMB. Okay, we have it's similar to this other one from WAEC 2014. So we have displacement and torque. I know we don't know torque yet, so we haven't dealt with torque. We will deal with this in coming classes, but then this is past questions, so they assume you're done with the 3 years course. So but then torque is not a vector quantity. All right, so we have displacement and torque as the vector pair, but let's still move on. Momentum and power, of course, we know momentum is a vector quantity, mass times velocity. Power is not a vector quantity. Acceleration and speed spoils it. Velocity and distance spoils this. So we have A as our answer, displacement and torque. Okay, so which of the following is not a vector quantity? This is from JAM 2008. We have altitude. Altitude is more like height, not a vector quantity. We have acceleration, of course. Acceleration is a vector quantity. We have displacement, of course, it's a vector quantity. We have weight. Now, I'm sure we know the difference between mass and weight. Weight is a vector quantity because weight is the pull of gravity on an object. Okay, so it has direction. We all know the pull of the gravity has direction. So weight cannot be defined by just magnitude. It has to have direction to be defined. And so, of course, weight is a force. So weight is a vector quantity. So we have altitude as the answer because it's not a vector quantity. Alright, so we move to solving number 6. Alright, 4 coplanar forces of magnitude 10 newtons, 17 newtons, 6 newtons, and 20 newtons act at a point 0, as shown in the above diagram. Determine the magnitude of the resultant force. Okay, this is from WAEC 2013. So let's see how that can be done. Let's try that. How do we solve these questions? We're asked to find the magnitude of the resultant force of 4 forces acting at a point O. So the first thing we do is to resolve them into their vertical and horizontal components. Alright, so in this case we have so let's start with the vertical components. So we have here 10 newtons. It has only effect in the vertical direction, has no effect in the horizontal because it's not slanted or tilted in any way. It's just a vertical force. So the vertical, so this is 10. So we'll put that down as 10. Even if we want to do 10 sine 90, we do 10 sine 90, we'll still get 10 because sine 90 is 1. You get, so this force has no business with the horizontal, it's just the vertical force. So we put down 10 newtons. Now we have 17 newtons. It has no business with the vertical, it's just the horizontal force. So we ignore that because if we even do 17 newtons cos theta, we're going to get 0. So we move down to 6. Of course, it's a vertical force. Okay, but then remember we have to note the direction. 10 newtons is positive vertical, 6 newtons is negative vertical. So we have 10 newtons plus minus 6 newtons. 20 newtons, of course, is a horizontal force, has no business with the vertical. So we sum this up to have 4 newtons. So we do the same for the horizontal components. Okay, 10 newtons and 6 newtons has no business with the horizontal, and because they are vertical forces, so we have plus 20 newtons and minus 17 newtons, and this gives us 3 newtons. Now we have resolved this into horizontal and vertical components. Alright, we can now solve to get the resultant by using the Pythagoras theorem. So after representing our forces in this triangular form, so we have 4 newtons, of course, as the vertical force, and then we have 3 newtons as the horizontal force. And we're trying to find the resultant C. Okay, we remember from the course that it's important for us to represent our vectors in the head to tail configuration. You can see this is tail to tail. Okay, so if we draw an equivalent line on this side, okay, you will see we have a triangle, right? And the line here will be 4 newtons. So of course I've always done this in class, and I believe there's the understanding of this already. But then if I draw a straight line here and I draw it till it coincides with the resultant, okay, we would have a triangle. Okay, and this part will be equal to this part, both in magnitude and direction. So we have 4 newtons on this side, and so we have the triangle that we can solve with Pythagoras theorem to get C. So C squared is equal to 3 squared plus 4 squared. If we simplify that, we have 9 plus 16, which gives us 25. We find the square root of both sides to have our answer as 5 newtons. Alright, so let's move on to number 7, and this is from 2015 WAEC, and it says, in a school compound, a girl walks 40 meters due east from the laboratory to the staff room to submit her report. Then she walks 30 meters due north to her classroom. Determine the magnitude of her displacement from the laboratory. Okay, alright, so if we have to put this in drawing, we'll have something like this. The girl walks 40 meters due east. We assume this is her point, okay, her first starting point. So she moves 40 meters due east, alright, from the laboratory of this from the laboratory to the staff room. So this is where the lab is, this is where the staff room is. She moves 40 kilometers to the staff room, alright, to submit her report. Then she walks 30 meters due north to her classroom. Determine the magnitude of her displacement from the laboratory. So we are asked to determine the magnitude of her displacement from this point. Okay, so it's quite simple. All we're asked to find is to find the resultant of this hand movement, and we can see it's already arranged in a tail to head format. So we simply bring in Pythagoras theorem as we did before to solve this problem, and of course c squared is equal to a squared plus b squared. Okay, we can take our a squared to be 30 meters, our b squared to be 40 meters, and we have 30 squared plus 40 squared, which gives us 2500. If you simplify that, find the square root of both sides, and we have 50 meters. Okay, so we have problem 8 to solve, and it says two forces 30 newtons and 40 newtons act at right angles to each other. Determine by scale drawing, alright, the magnitude and direction of the resultant force using a scale of 1 cm to 5 newtons. And this is a WAEC question, okay, from 2015, okay, paper 2 of the WAEC question of that year. So let's try to solve this graphically. Alright, so first of all, let's remember we are using a scale of 1 centimeter to 5 newtons. So we have our scale as 1 cm to 5 newtons. Okay, so these two forces are acting at right angles to each other. Okay, and the first one, okay, so let me just first of all draw two lines, two perpendicular lines. Okay, we use them for this whole thing. Okay, so these are two perpendicular lines, and we have 1 centimeter representing 5 units. So one of the forces is 30 newtons, which means it's going to be 6 cm, because 6 times 5 gives us 30. Alright, so let's take this to be our 6. Short, not long enough, so let's elongate the line. Let's extend the line. So we have this place to be 6 cm, which represents 30 newtons, and then we have the other one to be 40 newtons, which automatically will be 8 cm. Alright, 8 cm. So let's mark out 8 cm from this line. So we have that to be our 8 cm mark there. Okay, so we're asked to find the magnitude and direction of the resultant force. Alright, so okay, so this is a head. Alright, this is a head down here. Okay, but then to make this easy for us, let's get to draw another line here, so we can have tail to head and use the tail to head method to solve. Okay, I'm trying to get a perpendicular line here. Alright, so let's mark out 6 cm from it. Okay, so this will be 6 cm, and we have our head there. Okay, so we can see that, of course, we could join these guys together. Let's use dash lines. Alright, so we have gotten this line is same as this line, both in magnitude and direction. They are both equal lines in magnitude and direction. Alright, so our resultant now is this line that goes through, of course, remember what the law of triangles says. So our resultant line is the line that goes through this point. Okay, So if this is 6 cm and this is 8 cm, what's the length of this line? That will give us the value for the magnitude of our resultant. So let's measure it. If we do we'll see that we have 10 cm, okay, approximately 10 cm as the magnitude of that line. So what's the, let's find what angle, the angle there. Okay, if we do I'm trying to avoid the error of parallax. Alright, so if we do that, we'll see we have 30, coming from here we have 30 degrees, 35, so we have 36, 37, approximately 37.5 degrees. We could say 37.5 degrees because it's in between 37 and 38 degrees. Okay, so our magnitude becomes is 10 cm by 5 newtons, which is 50 newtons. Of course, I'm sure you know we're doing this because of the scale we used. Okay, we're converting our value here back to the actual value in newtons. Okay, so we have that as our magnitude and we have our direction as 37.5 degrees. Let's move on to question number 9 now. Two forces, each of 10 newtons, act on a body, one towards the north and the other towards the east. The magnitude and the direction of the resultant force are, we have this from JAM 2002. Okay, so if we represent this whole word problem as a diagram, we have two forces, each of 10 newtons. So you see the first force 10 newtons, the second force 10 newtons. One is acting towards the north, that's this one, and the other towards the east, that's this one. Okay, so this one is an equivalent line that represents this one, both in magnitude and direction. So if we do this, we already have, they're asking us to find the resultant force. So we can see we already have a triangle in this case, and we can still use same Pythagoras theorem to find the resultant, the magnitude of the resultant. So c squared equals to a squared plus b squared, we have that as 10 squared plus 10 squared, which gives us 200. So we find the square root of both sides and we have 14.14. Okay, but if you look at the options, we don't have any option for 14.14. Okay, so we convert this to this form, and then we have our answer hidden between B and C. So we found out that our magnitude is 10 root 2. So let's move on to find the angle. Okay, so the angle we're looking for here is alpha. So let's take the angle we're looking for here now to be alpha. That's this place. Okay, the angle the resultant makes with the x-axis. Okay, so if that's the case, then alpha can be found by tan theta. Okay, where of course we know tan theta is opposite over adjacent, and this is the opposite and this is the adjacent. So we have act tan 10 newtons over 10 newtons. Of course, you know it's supposed to be tan alpha equal to 10 newtons over 10 newtons. We make alpha the subject of formula to get arctan, 10 Newton over 10 Newton. So this is going to give us arctan 1, which is 45 degrees, and it is 45 degrees, okay, 45 degrees due east. So this is 45 degrees east, all right? And that we can see as number C. Okay, you can't say 45 degrees west because this is, the angle is here. Okay, west is this way. Okay, so this is 45 degrees east. So let's move on to number 10. And this question is from JAM 2007, and it says, the figure above shows 4 forces, 3 newtons, 10 newtons, 3 root 3 newtons, and 6 newtons, acting on a particle P. The resultant of the 4 forces is, or to find the resultant of the 4 forces. So what do we do? Alright, the only way to find the resultant in this case is still to resolve this into the vertical component and the horizontal component, and then we solve for the resultant as we do normally with triangles. Okay, so let's move on to resolve this into the vertical component and the horizontal component. So we start with the horizontal. So you can see that if we start from the 3 newtons, we have this as a horizontal force. It has no vertical component. So we put down 3 newtons plus 10 newtons has both a vertical and horizontal component. So the horizontal component, which is what we're looking for in this case, is 10 cos theta. Alright, and you check it's positive. This is the positive x region for 10 newtons. For 3 newtons, is also acting in the positive x region. So we now move on to 3 root 3. We can see this has no horizontal component. It's a vertical force and has no business with the horizontal. So we move on to the 6 newtons, and here we have a force that has both horizontal and vertical component. So we take the horizontal component, which is 6 cos 60, but then we have to note the fact it's on the negative x-axis. It's working opposite the other, so it has a negative sign. So if we simplify this, we're going to have 8.660. You can do this with a calculator. We have 8.660. Okay, then we'll do same for the vertical. We'll say that we have 3 root 3n plus 10 sine 30, because this 3 newtons has no vertical component. Okay, it has no vertical component, so we just have 3 root 3 newtons, all right, because this is vertical. Then the vertical component of 10 newton is 10 sine 30. Both of them are in the positive y-axis. Then we have 6 sine 60 for 6 newtons that is on the negative y-axis, so we remember to put our negative sign. Okay, so in that case our answer is 5. In that case our answer is 5. And then we now move on to try to find a resultant with triangles. Okay, so we have 5 newtons as the vertical component and 8.6 as the horizontal component. Alright, so and then if we solve that with the Pythagoras theorem rule, we're going to be having, okay, 5 squared plus 8.660 squared, which is 99.99. Find the square root of both sides. Alright, this is straightforward. We've done it over and over again. We're going to have 9.99, which is approximately 10. So we can see our answer is B, 10 newtons. Okay, so let's move on to the 11th question. The resultant of 2 forces, 12 newtons and 5 newtons, is 13 newtons. What is the angle between the 2 forces? From JAM 2008. Okay, so we represent this as a diagram here. We have 12 newtons and 5 newtons as the 2 forces, alright, and then we have 13 newtons. We just assumed they're acting at an angle. We don't know the angle. We're supposed to find the angle between both of them. So basically what we're going to do here now is we're going to assume this is a parallelogram, right? These 12 and 5 are adjacent sides of a parallelogram. Okay, and this is the diagonal that represents their resultant. Okay, so what we're going to do now is we're going to use the cosine rule to solve for this. So we have a root squared equal to a squared plus b squared minus 2ab cos theta. Now if you have to bring in our values into this, we're going to be having 13 squared, which is our arrow, okay, equal to 12 squared plus 5 squared minus 2 times 12 times 5 cos theta. That's from here. Alright, so that's, we'll simplify to get us 13 squared is 169, 12 squared is 144, 5 squared is 25, 2 times 12 times 5 is 120. But then we have to make theta the subject of formula, and you know what's going to happen there. Alright, we're going to have to move 169 over to this side. It becomes negative, so 169 minus 169 is obviously 0. So we have minus 120 cos theta equal to 0. Okay, so we have 169 minus 169. When 169 comes over to this side, okay, its sign changes from positive to negative because it has gone over the equality sign. Alright, so we're going to have here to be 0 and here to be minus 120 cos theta, which is equal to 0, making theta the subject of formula. In this case, we have 0 divided by 120 equal to minus cos theta, which is 0. Okay, so if we find the act cos of 0, we're going to have 90 degrees. Okay, so our answer is C, 90 degrees. Okay, so we move on to number 12. Alright, the figure shows two vectors at right angle to each other. The value of the resultant vector is, this is from JAM 2011. Okay, so we have to find the value of the resultant vector. This is simple, still same thing. We use Pythagoras theorem to solve this and we get our answer. Okay, a squared plus b squared is 6 squared plus 8 squared, which is 36 plus 68. Find the root of square root of both sides. We have C to be 10 newtons, which is D. Okay, number 13. The resultant of two forces is 50 newtons if the forces are perpendicular to each other and one of them makes an angle of 30 degrees with the resultant. Find its magnitude. Of course, so we get to draw two perpendicular lines and we know that the resultant makes an angle of 30 degrees to one of the forces. So this is depicted here. So how do we find the resultant? Okay, so we're looking for the value of this force that makes an angle of 30 degrees with the resultant. Okay, so remember we did resolution of vectors where we split a single vector into its component vectors. Okay, so in this case we're not looking for both of its component vectors, that's the vertical and the horizontal. All we're looking for is the horizontal vector. Okay, so all we need to do is resolve this resultant into its horizontal component, and that's simply 50 cos 30. Okay, 50 cos 30 will give us 43.3 newtons. So this force here is 43.3 newtons. So let's move on to the last question, number 14. An object is acted upon by two forces, 5 newtons and 12 newtons. Calculate the resultant of the forces acting at an angle of 120 degrees to each other. This is from JAM 2020. So this is a depiction of the question. We have two forces, 5 newtons, 12 newtons, acting at an angle of 120 to each other. Okay, alright, so we're going to solve this using the parallelogram law of forces. Okay, so if we convert this into a parallelogram, if we try to make this a parallelogram, from the parallelogram law of forces, we'll see that this line here would be our resultant. Okay, so we could use the cosine rule to solve this, or we could use a modification of the cosine rule, which is what I have here. Okay, to solve this using this angle between both forces. Alright, but if we're using the normal cosine rule, we can't use this angle between both forces. Okay, so let's use the shortcut which was taught in class, using the angle between both forces to solve the problem. So if we do that here, of course cosine rule has negative sign here, but we change the negative sign here to positive to use the angle between both forces, which is 120 degrees. Bringing in our parameters, we have 5 squared plus 12 squared for a squared and b squared. So we have arrow squared equal to 5 squared plus 12 squared plus 2 times 5 times 12 cos theta, where a is 5, b is 12. Okay, both sides of the parallelogram. Right, so our theta is 120. We bring that in here, then we simplify this. 2 times 5 times 12 give us 120. Alright, so we simplify that, add it to 169, and we have 109. Of course, cos 120 is minus 0.5. So if we simplify all this, we have 169 minus 60 equals to 109, right? We find the square root of 109 and we'll have our answer as 10.4 newtons. Alright, so this is using the shortcut. If we want to solve this using the cosine rule, we'll have to bring out the triangle from this equation. Okay, so we have here as 12, we have here as 5. Alright, so this is this triangle here. We have brought out this triangle here. Okay, I know it's not perfect, but that's what we have. We're trying to solve this triangle now to get our angle. So if you look at this carefully, you'll see that we don't have that 120, the angle of 120 here. Okay, we don't have it. Where we have the angle 120 is if we extend this part, it's the angle this force makes. Of course, both forces make with themselves. So if we extend this force to this way, it's the angle this other force makes with this one. So the 120 degrees is here outside the triangle. If we look at this is a straight line. So angles in a straight line sum up to 180. So 180 minus 120 would give us, okay, this angle as 60 degrees. So we can use this place as our A, okay, use here as our B, alright, and here our resultant, which is our arrow. Of course, our resultant is here, this place. Okay, so that's our arrow. So we can now use this arrangement to find arrow with the cosine rule. Okay, so if we're doing that, in our case, we're going to be having arrow squared, okay, will now be equals 5 squared plus 12 squared, okay, minus now we're going to have minus here, minus 2 times 5, okay, times 12, then cos 60. All right, so if we simplify this, of course we could put a bracket here, we could put a bracket across these numbers, so we know the minus sign affects everything within the bracket. Okay, so if we simplify this, of course we're going to have arrow squared equals 169, okay, minus 2 times 5 times 12 will give us 120, cos 60 is 0.5. 120 times 0.5 is 60. Okay, so we have that. Don't forget this is still arrow squared here. So this 169 minus 60 will give us 109. Right? So we find the square root of 109 to get r, and that will give us our answer as 10.4 newtons. So this is how we solve to get our answer using the cosine rule. But here now we did this so that we can take advantage of time, just in case we don't have enough time. Don't forget, you only use this formula if you're trying to find the resultant using the theta, that is the angle between both forces. Okay, in this kind of arrangement, first of all, observe that they are not in a tail to head arrangement. Okay, and the angle between them was given, so you can just use that angle straight as your theta, and then bring in your A and B as the two forces and solve and get your answer using a positive sign to replace the negative here from cosine rule. But the normal way to do this is to put them in the tail to head arrangement. Use this 120 degrees I was given to you as the angle between both forces to find an angle inside the triangle that you would form from two sides of the parallelogram and the resultant. Okay, find that angle, then use that angle now to solve for your arrow using the cosine rule formula.